Hi guys, in the previous lecture we have solved network theory problem that has been asked in Engineering Services Examination 2018. Now in this lecture we will continue with some more problem. So let's get started. See this problem. This has been asked in ESE 2018. The current in the 1 ohm resistor in the network shown is, we have to find the current in 1 ohm resistor. This is the 1 ohm resistor. Okay. Now, in order to find the current in 1 ohm resistor, what we can do? We can apply the nodal equation at node V. Let us say this is node V and this is the reference node. Okay. So at node V, write the nodal equation, that is V minus 2 by 2 plus V minus 3 by 2 plus V by 1 minus 2 ampere is entering the node, minus 2 is equal to 0. So after solving this equation you will get V is equal to 9 by 4 volt. So I can easily write I is equal to V by 1. This is the reference node and V is the total voltage across it. So current flowing in 1 ohm resistor will be V by 1, that is equal to 9 by 4 ampere, that is equal to 2.25 ampere. So option B is correct. There is another way of solving this problem. Let us see the method 2. The method 2 is by using source transformation. See here, this is practical voltage source, 2 volt voltage source in series with 2 ohm resistor. So convert this practical voltage source into practical current source. It will be like one current source having polarity like this, and the value will be 2 by 2, that is 1 ampere. You have to use the source transformation in parallel with this 2 ohm. Okay, again this convert this practical voltage source into practical current source. You will get something like practical current source 1.5 ampere, 3 by 2 is nothing but 1.5 ampere, and in parallel with 2 ohm, and again in parallel with 1 ohm and 2 ampere. This is 2 ampere current source. Now find the equivalent current. See, 1 ampere is from down to up, 1.5 ampere is also from down to up, and 2 ampere is also from down to up. So it will be 1 plus 2, that is 3, plus 1.5, total will be 4.5 ampere from down to up. Now this 2 ohm and this 2 ohm are in parallel, so equivalent will be 1 ohm, and you have to find the current in this 1 ohm resistor. This is the current. So two resistors are connected in parallel having equal magnitude, so current will divide equally, and the value of I will be equal to 4.5 by 2, that is equal to 2.25 ampere. So you can go by any method. In this question, if you will apply source transformation, then it will be easier for you. Now move to the next question. This is the transient question. What is saying, for the circuit shown, consider that switch S1 has been in position B for a very long time. S1 is at position B for a very long time, means the network is at a steady state, and switch S2 has been open for all the time. Okay, at time t is equal to 0, the switch S1 moved to position A and switch S2 closed instantaneously. At t is equal to 0, the switch S1 moved from position B to A and S2 has been closed. So what is the value of V out? V out is the voltage across this capacitor at t is equal to 0 plus, assuming initial charge on C capacitor is 0, means initial voltage across this capacitor is 0. So how to solve this type of problem? Let us draw the circuit for t less than 0. For t less than 0, network is at a steady state. For t less than 0, this switch S1 is at B. So 10 ampere current source, this is 10 ampere. Now this is point B, and from B, this is point B, S1 is connected at B, and now this inductor is connected like this, right? And this is open circuit. This is capacitor. For t less than 0, switch S2 is open. Now for t less than 0, this network is at a steady state, therefore this inductor can be replaced by short circuit. The concept has been discussed in transient lecture. So you can easily find IL of 0 minus. So IL of 0 minus is nothing but the value of current source only, because there is only one path. So it will be equal to 10 ampere, and we know that inductor won't allow sudden change in current. So IL of 0 minus must be equal to IL of 0 plus. Now draw the equivalent circuit at t is equal to 0 plus. What I told you in my lecture, at t is equal to 0 plus, inductor can be replaced by current source and capacitor can be replaced by voltage source, provided the value of current source and voltage source will be equal to the value of current at t is equal to 0. Okay. So draw the equivalent circuit at t is equal to 0 plus. Now at t is equal to 0 plus, switch S1 is moved to A point. So this is A point. Now this switch S1 is connected and this is inductor. At t is equal to 0 plus, I told you inductor can be replaced by current source having value at t is equal to 0 that we have derived, that is IL of 0 minus is equal to IL of 0 plus, that is equal to 10 ampere. So at t is equal to 0 plus, inductor can be replaced by current source. Okay. Now this switch S2 is closed. So close this S2 switch having resistor R is equal to 2 ohm. Now capacitor can be replaced by voltage source having value Vc of 0. I told you in my previous lecture when I was teaching you the transient, that at t is equal to 0 plus, inductor can be replaced by current source having value IL of 0 and capacitor can be replaced by voltage source having value Vc of 0. Okay, we have to find this value, we have to find this V out. So you can see that, is the capacitor is charged at t is equal to 0? No. So capacitor is not charged at t is equal to 0. Capacitor is not charged at t is equal to 0 minus means Vc of 0 minus is equal to 0, and we know that capacitor won't allow sudden change in current, so it will be equal to Vc of 0 plus. So what I am getting, V out at t is equal to 0 plus will be equal to 0 volt. Since the capacitor is not charged for t less than 0, therefore at t is equal to 0 plus we won't get the capacitor voltage, so it will be equal to 0 volt. So option D is correct. See the next question. What is the phasor sum of current I1 and I2 given for two complex operators which are individually defined by AQ is equal to 1 and J square is equal to minus 1. So we have to find the net current, that is equal to I1 plus I2. I1 is 10 into A minus A square and I2 is minus J10. Okay, so net current will be written like this. Now we know that 1 plus A square is equal to 0. So from here A square I can easily say it will be equal to minus 1 plus A. So put the value of A square in this equation, you will get I net is equal to 10 into A plus 1 plus A minus J10. So it will be equal to 20A minus J10. So 10 minus J10 plus 20 at an angle of 120, as we know that the value of A is 1 at an angle of 120. So it will be equal to 10 minus J10 plus 20 cos 120 plus J sin 120. So overall it will be equal to J into 20 sin 120 minus 10, that is equal to 7.32 at an angle of 90. So option B is correct. See the next problem. A series RLC circuit has a resistance of 50 ohm, inductance this much and a capacitor of 10 microfarad. The circuit is connected across 100 volt AC supply. The resonance frequency and the current through resistance are. This concept has been discussed in series resonance as well as in AC circuit, that is series RLC circuit. A series RLC circuit is connected with 100 volt. This is 100 volt. This is the value of R. Let us say the inductive reactance is XL and capacitive reactance is XC. It will be JXL, it will be minus JXC. So at resonance frequency, we have to put the imaginary part of Z is equal to 0. We have discussed these all concept at resonance. So it will be XL is equal to XC, that means omega L is equal to 1 upon omega C. So omega will be equal to 1 by under root LC. See, in option, the frequency, the resonance frequency is given in radian per second. So you have to find the value of omega, that is equal to 1 by under root LC, and the value of L is 0.4 Henry and the value of C is 10 microfarad. That will be equal to 500 radian per second. Okay, now the second thing is we have to find the current at resonance. So at resonance, current is maximum. We know that I max, and that is equal to V upon R, because Z is equal to R plus J into XL minus XC. At resonance, XL is equal to XC, so this J term will cancel out. So only the impedance will be equal to the resistance, purely resistive circuit. The circuit will behave like a resistive circuit. So I max at resonance will be equal to V upon R, that is equal to 100 upon 50, so 2 ampere. So finally I am getting resonance frequency is equal to 500 radian per second and current is 2 ampere at resonance. So option A is correct. These all concepts I have discussed in series resonance as well as in AC circuit. So go through that lecture. See the next problem. A pulse of 10 volt in magnitude and 2 second in duration is applied to the terminal of lossless inductor. First make the lossless inductor. This is inductor. And we are supplying one pulse, let us say V, and the value of V in waveform is pulse of 10 volt is applied till 2 second. After that it is 0. This is 10 volt. Okay, this is applied to a lossless inductor of having value 1 Henry. The current through inductor would be, so what is the value of current? IL of t is equal to 1 upon L integration of V dt. Now the value of L is equal to 1 Henry, so it will be equal to integration of V dt. And value of V, the voltage waveform is given as in the form of pulse having peak value that is equal to 10 volt. So integrate this up to 2 second, you will get from 0 to 2 10 dt, it will be equal to 20 ampere. So IL at 2 second will be equal to 20 ampere. Now we know that integration of a square or rectangular pulse will give me the straight line. It is 10t, so it will be something like this from 0 to 2, and the peak value will be equal to 20 ampere. This is V and this is equation of IT, right? Now what will happen after t is equal to 2 second? See, after t is equal to 2 second, the voltage having value 0, we are making V is equal to 0, means it can be replaced by short circuit. So short circuit the voltage source. Now this inductor is having some energy. Okay, so it will behave like a current source having value 20 ampere. And this current source, this energy will not get dissipated across any element because only lossless inductor is present. So what is happening from 0 to 2 second, the inductor is charging from 0 ampere to 20 ampere, and after that it is not discharging because no any resistor is present in the circuit. So it will become, the current will become constant after 2 second, and it will continue to constant till t is equal to infinite. So which option is matching? See the option A, the inductor current be a pulse of 20 ampere for the duration of 2 seconds, wrong. Be a pulse of minus 20 ampere, no, only positive. See, increase linearly from 0 to 20 ampere. See, it is increasing linearly from 0 to 20 ampere, and after that from theorem it remains constant at 20 ampere. So option C is matching with this condition, hence option C is correct. See the next problem. This is very good problem. In terms of ABCD parameter of a two-port network, the parameter ZA, ZB, ZC of a equivalent T network are respectively. We have to find the ZA, ZB, ZC in terms of ABCD parameter. So this is T network, right? This is ZA, this is ZB, and this is ZC, and this is T network. Okay, and we have to find the value of ZA, ZB, ZC in terms of ABCD. So how will I find? Let us see. This is V1, this is V2, this is I1, and this is I2, and here the current will be I1 plus I2. So write the KVL equation on input side. It will be equal to V1 is equal to ZA plus ZC into I1 plus ZC into I2. Similarly, I can write V2 is equal to, write KVL equation on the outer side. It will be equal to ZC into I1 plus ZB plus ZC into I2. This is Z parameter of T network. I already explained in lecture number 19 how to find the Z parameter of T network. Okay, let us say this is equation 1 and this is equation 2. So from equation 2 I can write the value of I1. I1 will be equal to 1 upon ZC into V2 minus ZB plus ZC upon ZC into I2. I can write like this. Now we know that ABCD parameter equation V1 is equal to what? AV2 minus BI2, and I1 is equal to CV2 minus DI2. So comparing this equation with this equation, I can easily say C is nothing but 1 upon ZC. So ZC will be equal to 1 upon C. I got this ZC. Similarly, I can write D is equal to ZB plus ZC upon ZC. So from here, ZB is equal to D into ZC minus ZC. That will be equal to D by C minus 1 by C. It will be equal to D minus 1 by C. So finally I am getting ZB is equal to D minus 1 by C. So we got ZB and ZC. Now we have to find the value of ZA. So in order to find the value of ZA, what we have to do? We have to put the value of I1. This is the value of I1 in this equation. Okay, replace this I1 by using this. What we get? It will be equal to V1 is equal to ZA plus ZC into I1. I1 is nothing but 1 upon ZCV2 minus ZB plus ZC upon ZC I2 and plus ZC I2. Now compare this V1 with the original ABCD parameter. So A, the value of A is the coefficient of V2. So coefficient of V2 is nothing but ZA plus ZC by ZC. Coefficient of V2, that is equal to A, that is equal to ZA plus ZC upon ZC. So from here, ZA will be equal to A into ZC minus ZC, and we already found the value of ZC, that is 1 upon C. So it will be A upon C minus 1 upon C, that is equal to A minus 1 upon C. So finally what I am getting? I am getting ZA is equal to A minus 1 upon C, ZB equal to D minus 1 upon C, and ZC is equal to 1 upon C. So option A is matching with this expression. So option A is correct. Okay. Now see the next question. Again, this is a T network and we have to find the Z parameter. So for T network, I have already explained you in lecture number 19 how to find the Z parameter of any T network. Z parameter of any T network will be equal to ZA plus ZC. This is ZC, this is ZC, this is ZB plus ZC. Now see the question. ZA is equal to 8 ohm, ZB is equal to 2 ohm, and ZC is equal to 4 ohm. So what will be equal to Z11? Z11 will be equal to ZA plus ZC, that is equal to 12. Z12, that is equal to ZC 4. Z21 is 4. And Z22 is equal to ZB plus ZC, that is 6. So 12, 4, 4, 6, only option 1 is matching. So option A is correct. The concept has been discussed in lecture number 19 of network theory. See the next question. In the circuit as shown in figure, the switch is closed at t is equal to 0. The current through the capacitor will decrease exponentially with the time constant. We have to find the time constant of this circuit. So close the circuit. This is having voltage of 10 volt. So 10 volt will drop across here only because these two are connected in parallel. Okay. Now in order to find the time constant, what I told you? I told you to short circuit the voltage source and open circuit the current source and find the region where R and C are separable. So first short circuit this voltage source. This is 1 ohm. This is 1 ohm. This is C having 1 farad. This is also 1 ohm. This is also 1 ohm. Now find the region where the value of R and C are separable. So this is the reason where the value of R and C are separable. So find the R equivalent across it and C equivalent across this AB terminal. So what will be the R equivalent across AB terminal? See, this is sorted. This resistor is sorted, means this is of no use. So R equivalent will be equal to 1 ohm and C equivalent will be equal to 1 farad. So time constant will be equal to RC, that is equal to 1 second. So option B is correct. This concept has been discussed in, I think, lecture number 13, 14, 15. Okay. Now see the last problem. That is, a parallel plate capacitor with air between the plate has a capacitance of 10 picofarad. One parallel plate capacitor is there having distance D and area A. Okay. And the value of C is given, that is equal to 10 picofarad. If the distance between the parallel plate is half, now what I am doing? I am reducing the distance. This is D by 2 and the space between the plate is filled with a material of dielectric constant 5. Here the value of epsilon naught R is 5. The newly formed capacitor will have a capacitance what? We know that C is equal to A epsilon naught upon D. Okay. Here area, we are not changing the area of parallel plate. So area is constant. So C proportional to, let us say this is relative parameter epsilon naught epsilon R. So C proportional to epsilon R upon D. So I can say that C1 C2 upon C1 is equal to epsilon 2 upon epsilon 1 multiplied by D1 upon D2. What is the value of epsilon 2? That is equal to 5. Initially it was 1 multiplied by D1. D1 is D and D2 is half, that is D by 2. So it will be equal to 10. So what I am getting? I am getting C2 upon C1 is equal to 10. So new capacitance C2 will be equal to 10 of C1 and the value of C1 is 10 picofarad. So it will be 100 picofarad. So option C is correct. So in this way you can solve the previous year ESE problem that has been asked in 2018 from the subject network theory. So if I will have to conclude how many of question are asked in ESE 2018 from the network theory, so you can see from the basic concept the 9 question has been asked, from network theorem 3 questions, transient 2 port network 2 question and AC circuit 4 question. So total of 20 questions has been asked in ESE prelims in EE domain and one question carry 2 marks. So total of 40 marks of question has been asked from network theory. So it is really important to have a very good understanding in this subject. That's all about this lecture. See you in the next lecture.